Sometimes I'm surprised I remember that stuff, to be honest, because I only do it once a year when we get to this stuff, but it's pretty fun stuff. All right, what are your questions, bud?
It's just some final questions that I see I don't remember doing.
Okay.
Like one of them was something me and Riker tried to do, but we couldn't remember.
Okay. Did you share it with me or no?
I have the photos already.
Okay, go ahead. Throw them up there.
Like um I put it on the left side, like
Oh,
on
you
the tippy
did.
top.
Okay, give me a second. I'm telling Riker to join my live stream so that he can watch this. Okay, this one right here, 7.
Yeah, like we didn't remember how to start it off. Like we knew like the end steps, but not the first steps.
Okay, identify the max error when using that to approximate that. Okay, so basically you're just going to plug in this value for x here. Um,
Okay.
let me think on that to that. I'm trying to remember how what were get me started on this because I don't remember how. I remember helping you with one of these the other day, but I can't remember.
Yeah, I'll find it in my note. I'll find it in my notebook.
I feel like you take on that interval, you're trying to identify the maximum error when using that to approximate that. Um, so yeah, so that is a so you're using basically just the first four terms, right?
Yeah.
So I'm just trying to think of what you do um with the bounds of that. Identify the maximum error when using that expression to approximate the infinite. That's the infinite sum. Approximate the infinite sum. Um,
So from what I see in my notes, I have it pulled up for when I did like a apparently the 6th of November,
okay.
where we put in the 6
Point
into
point
the
six for
yeah,
x.
the point 6 into the x of the equation and get
Uh-huh.
that decimal, and
Okay.
then put the point 6 into the x of the sequence and add those up.
Right.
And then to find the error, you would do the absolute value of
The difference
the
between them.
equation minus the sequence. You get
Okay,
your error.
but why are you doing point 0.6 and not 1.2? Like how do you know why are you putting point 0.6 in and why are you not using 1.2?
Oh,
You get what I'm saying?
it is 1.2 is also 1.2 is also it's another x. Oh,
So you do that as well.
uh,
The maximum error. So that's what I'm wondering. Do you just put both of them in and whichever difference is bigger, that's what you use? That's what I'm wondering. So if I plugged in point 0.6 for all these and point 0.6 here, find out what the difference is between that, and then put 1.2 in for all the x's and 1.2 in for the x here, and then find out the difference between those. And then whichever of those two differences is bigger is the max error.
yeah. Um,
I'm
that might
guessing
be.
I'm guessing that's what you do. I'm feeling like that's what you do, but I just don't know if there's a shortcut way of doing that. I would
Yeah.
use the store. I would probably use the store button
Yeah.
on your calculator.
Yeah, I'm doing that right now. Like so for the point 0.6, the sequence addition is 1.248.
Okay.
And then
1.248. Don't round it.
yeah, it's not rounded. That's the whole
Yeah.
thing.
Okay.
Then 1 minus 3. 1.25 for the equation with point 0.6.
Okay. 1.25. Okay.
Then the absolute value of 1.25 minus 1.248 would be 0.002 would be the error for that.
0.002. Okay.
Yeah. And now if we have x equals 1.2,
Okay. So that's for when X was zero point 0.6.
mhm,
Okay.
the sequence would be 1.624.
Uh-huh.
And the equation would be 1.666 continuing.
Okay. And subtract them, and what do you get?
I'm gonna round the 1.6 continuing to 1.6667.
Okay.
Yeah. And I
You did
got,
you didn't have to round it. You could have just subtracted 1.624 from it.
oh, hmm. I got 0.0427.
Yeah, that's rounded. So the maximum error would be that would be your maximum error because that's bigger than the other one.
Okay.
So your max error is going to occur at one end or the other, I suppose, is what the assumption is there.
Hmm.
So you find both endpoints and you find out which error was bigger. Is that what you did in your notes? Does that seem right?
Yeah, it
Or
does seem like that.
yeah, I actually don't remember ever teaching this. And I know I've done it before, but it's just kind of it's a different topic than what I did when I taught this class. I don't remember ever teaching with this. That was a long time ago though.
Oh.
But that feels about right. Is that the answer? Do you have the answer key with you?
No, my teacher, Mr. Gambino, did not offer any answer key for any of the practice.
Okay. Do you have another max error or problem like that or no? Or do you want to
I've
move on?
checked through all four of the worksheets. I could not find another error one.
Yeah, there's not, that's what I'm saying. Like it's not a very common thing to do. I don't do very many of those problems and I can't quite remember. I mean, I understand what they're saying here. Basically, what they're saying, it seems to me, is you have this geometric sequence, right? Or
Hmm.
series, this geometric series, because you're adding the elements of a sequence together. But this is just cut off. This is just the first four terms of it.
Yeah.
And this is the entire infinite. This is infinite.
Hmm.
And you're looking at what basically for the x values between here and here, you're basically trying to find out what the error could be because you're basically going to have a rounding error here, right?
Hmm.
Because
Yeah.
you rounded that. So getting the two endpoints, I suppose using the two endpoints would basically give you the maximum. That's the assumption there.
Yeah.
Using the two endpoints, the max or the min would have to occur on one of those two endpoints.
Mhm.
I don't really know why that's true. I imagine like this sequence being something like this, right? And the other one being something like, let's see if I multiply that by, I don't even know what that function is, what this function would look like. But basically the other function would be, I don't know, another function like this or something.
Mm.
Well, they wouldn't be intersecting like that. It'd be like this, maybe. I don't know. And so
Yeah.
the endpoints, this is what I'm saying. I don't understand why the endpoints would have to be where the max error would be. Those those endpoints. I don't know why couldn't there be a bigger error in here?
Mm.
I just don't quite understand it. Maybe my pictures must be wrong because it certainly I believe that's the way you do it. It seems like that's the way you do it, but I just don't remember ever teaching this. I don't quite get the concept here why we're what we're talking about.
Uh,
Like what
And
what application this has to anything. I just don't quite get it.
yeah, and like yesterday in the tutor when you went out for the phone call, me and Riker we went on our each other's like daily slideshow of the whole of this whole semester looking for our teacher explaining it and we couldn't find any.
Right, right. That's what I'm saying. I feel like we've had this conversation before. I just don't remember ever seeing notes on it. So
Hmm.
anyway,
Um, I have another question I want help with,
yeah,
mainly because what they're asking for, I don't remember how to do it.
okay,
So they're asking me to solve this by completing the square, but
yeah,
I don't remember what was completing the square. Like I know how to do factoring, I know how to do
yeah.
that quadratic formula, but I don't remember completing the squares.
Okay, so completing the square is actually a really cool trick, and it's the third way that you learn to solve, or maybe the fourth way that you learn to solve a quadratic equation. And basically, what completing the square does is it takes a standard form equation like this and it turns it into vertex form so that you can solve it more easily and you can see the vertex easily. So let me show you how you do that. So completing the square means that you're making it a perfect
Square.
square trinomial. That's what you're doing. So I want to turn this into, you remember vertex form? This is vertex form
Hmm.
plus k maybe. Remember that?
Yeah, I think so. Yeah.
That's vertex form versus standard form, which is ax squared plus bx plus c equals 0
Hmm.
or equals y. I should say y. This is standard form, like what you have here. And this is vertex form, where your vertex is h comma k. And look at the advantage of something like this. If I had 5 times x minus 3 squared plus 2 equals 0, how can I solve this equation?
You would subtract the two,
Exactly. It's very simple to solve, right? I
hmm,
subtract the 2, I divide by 5, I take the square
square
root,
it,
and I
and
add 3. You could almost do it all in one stroke like that.
hmm,
See how nice that is?
yeah.
That's why we want to complete the square. So we're trying to put this into that form. Okay. So the way to
Hmm.
do it when there's when a is something other than one is you first factor that out of the two x terms. So I'm factoring that out, and then I'm leaving the 5 on the outside like this. So you see what I did there?
Yeah.
Okay. Now take half of what this is and square it. What's half of -2?
Half of -2 would be technically -1.
Right? And square it. So what do you get?
1.
Good. And then add that inside of here, but you can't just add something inside of there. You have to also add it on the outside, right? Or subtract it on the outside or add it to the other side. You have to balance your equation out, right? So I'm
Hmm.
also going to, oops, I'm leaving a little space here. I'm going to also add or subtract 2 times 1 from the outside. Why 2? Because really, when I put that 1 inside there, when I added that 1 in here, I really added 2 times 1, didn't I? For you.
Yeah.
So I have to subtract 2 times 1. Okay. Now, why do all this? Why am I doing this mess? Well, because now this perfect square trinomial, right, factors into x minus 1 squared.
Mm.
And that is plus 3 on the outside because I'm simplifying that. So this equation right here is the vertex form for this standard form equation.
Okay.
So to solve this by completing the square now, I'll simply, like I said before, I just have to move the 3 over, divide by 2, take the square root of it, plus or minus, and then add 1. And that's my x, which is 1 plus or minus I root 3 over 2.
Okay.
That's completing the square.
Got it.
By completing the square. You want to ask another one? Find another one?
Um, yeah, I have another question. It's kind of like a review of the last unit of limits, just kind of trying to re refresh my
Uh-huh.
memory.
Sure. So this is, notice this is a rational function, right? And you remember the limit, this is saying what's the limit as x goes to infinity. Well, what they're really asking, if I were to draw this, I'm just going to do this really quick. If I were to draw this graph out, the graph of this thing, just very quickly, remember how to do this? The denominator, setting the denominator equal to 0, if possible,
Hmm.
which isn't possible, right? No solution.
Yeah, no solution.
That would have given you your vertical asymptotes. So there's no vertical asymptotes.
And wasn't it to find horizontal isotopes is if the powers are the same, you would
Exactly.
subtract or divide the
No,
coefficient?
just divide them. So the
Divide.
horizontal asymptote is y equals 7/3. Exactly. And what does that mean for it to be a horizontal asymptote?
That means it can't go higher than
Yeah.
7/3.
So 7/3 is right here. So that's my horizontal asymptote. What does that mean is happening as x goes further and further to the left this way? What happens? What
As
happens?
it goes further to the left, it would it would fall to seven
That's right.
thirds,
It would fall to 7/3. So what's the limit as x goes to negative infinity? What is the y value getting closer to?
7/3.
7/3, exactly. So the
Okay.
limit of that is just the now that's the pictorial, the graphical way to think about it.
Hmm.
Algebraically, the way you think about it, what they teach you is just look at your leading coefficients. That's all you have to
Yeah.
worry about.
Okay.
And or another way you could do it is like a calculus way, divide everything by x squared. If you divided all the things on the top and bottom by x squared, then you would get everything gets divided by x squared. Then you would have 7 minus 3 over x plus 2 over x squared all over 3 plus 8 over x squared. And when x gets bigger and bigger and bigger, negative, what's happening to all of these things here?
It
What's,
will get smaller.
yeah,
So
it
so
gets
so their effect would be like useless.
exactly. And that leaves you with 7.
7/3.
Yep. So that's another way to think about that. Okay.
Yeah. I'm not sure how much time I have left because I was a bit late, but can you help me answer one question?
Sure. Yeah.
This question is basically asking you, or is asking a person if it's continuous or discontinuous, and if so, where are the isotopes or holes?
Yep. So plug in 1 to this one and plug into 1 to this one and see if they're the same point.
Okay,
So when I
so
plug
for
1 there, I get 2 minus 1, which is
one,
1. And when I plug in 1 here, I get 1.
one,
So are they going to touch each other at that point?
they would,
Yep. They'll touch
yeah,
each other. Yep.
yeah,
So it is continuous.
okay, yeah, and when you graph it, the one would have a like would have a hollow circle and on top and it would also have a solid circle also.
Exactly.
So it would
Exactly. It
continue.
would fill it in. Yep, exactly. And one of them would be an upside down parabola, right? And
Hmm.
the other one would be a line, but they would be touching at that point.
Hmm.
Yep.
Okay. Yeah. That